Little pause you heard in the sounds and the sigh was another nice cameo from good old Eamon. Always loves to start his cries, right when I'm trying to finish off my videos. But point that I'm trying to make there is that if you keep navigating, eventually you'll get to this sort of pro NBD file here that we created, or you can pick the one from the desktop folder. I'm going to use the Pro and just sort of ignore the fact that we don't have the restrictions. It's totally fine with me. I just want to demonstrate the cost variables here. But you could pick this, come on in until you find the network data set, pick it, and hit OK. And then just come on up and confirm that's what you have. Boom, I've got this. So what this means is that network data set we created in the last video, that's what it's going to run on. So now that we have that, let's start with root. And root is the simplest one. Root really is this point to this point, right? Calculating the shortest distance and the shortest time. So give it a moment. Always takes a second to load, obviously. And we'll spend the next sort of 5 or so minutes of this video really seeing the various ways that root works. We'll run it for distance, we'll run it for time, and then after that at the end we'll run it for that crime cost that I had layered earlier. So when you load it, it makes this sort of layer here, right? Root, stops, point barriers, line barriers, polygon barriers. And what we're going to do is you see that this little window has opened up for the first time, Network Analyst Root. So if I come on over and click this, I've got a bunch of information that I can play with. Well, let's do run last and start here with import stops. Because when you're running root, right, the purpose of root is how do I move between one point and another, right? How do I get to point A? How do I get from point A to point B? And so if these are the 2 points right here that I want to measure, we're going to do them first and then we'll do RP crime later. I need to load these points so that I know where my start and my stop is. And you do that by clicking on the import stops. So a supplementary window will open. That's going to prompt us in a second to add the locations. And then from there, we'll actually calculate the root. Again, always such absurd and preposterous preamble. There we go. All right, so ignore this for now. Come on over here, and we're going to input the root points as our locations. Maybe later in an advanced technique video, we'll talk a little bit about these field mappings. As you're learning this, don't worry about them. Only other thing we really need to know here is the sort field, because that'll tell you what should be the first and the second. I loaded it into my data. I actually labeled one of the root points 1 and one of them 2. We'll hit run, and then what you'll see in a second is the number 1 appear here and then the number 2 appear here, and we'll be good to go. Again, this video is really testing one's patience and how long it makes you wait for the points. All right, so it's loaded. We are good to go. Let's X out of the add locations. And I want you to actually, before you do anything, the only other big thing we need is here under travel settings. Come on down here and click this. And this, under travel mode, is where the fruits of our labor come out. Ignore all of this. We didn't build these custom travel modes. All that matters is here under cost. And if I go to cost, suddenly I can see the 3 things we built. The cost being length, the distance between several things. The cost being minutes, the amount of time it takes. The cost being this abstract. And let's actually play with each of these. Let's take length and hit OK. And all we've done here is say, I want you to show me the quickest route between this point and this point on just distance. And I'll hit run, and it's going to be using this network, measuring the distance of each road such that the result that comes back to me will map out the quickest, or sorry, the shortest in terms of distance route between these points. And here we go. 1 and 2 and 3, and there we go, right? That is the shortest distance. But what about time, right? Wouldn't it be quicker if I actually rode on the expressways because their miles per hour is greater and I could actually sort of process them a little quicker? And so let's come on in and let's actually change this in the costs to minutes. And then come on here and run the same thing. And what you will see is the route will no longer just find the shortest distance, right? The path of least resistance. Its new cost will be time. And since highways are quicker in our equation, right? But we have a very simple equation. We didn't incorporate things like traffic or time of day. It's just simply that you could move on them faster. This would actually be the lowest quote unquote cost route. And now you can really start to see the fruits of our labor that we built in building these network data sets. Last thing to close this, I want you to drag in the crime layer. Again, unless you're operating on the same map you built the network data set from, it's going to show up as first as this exclamation point. So make sure you navigate from clicking that to the crime layer. And, to me, this is actually best demonstrated. I'm going to have to run the click on route again. I'm going to run this as a distance again really quick, just so you can sort of see the payoff. So if I go back and pick the crime as length. And those of you who are using the network data set that is that we created in desktop and not pro, you might as well turn on and off the restrictions. You'll see sort of the option under the restrictions tab to do that. Play around with it and see how it changes your route if you allow one way to be a thing or sort of not. But again, those using Pro, we didn't sort of load that because of the time that would be allowed. All right, so we're going to run it. It's going to sort of show the shortest path. Hopefully. Did I mess this up? I may have. Travel settings need to be length. Maybe, there we go. Sorry. Just took a second. So we've got length, our shortest distance. But notice that to do that, it passes through a couple areas where the crime is a little higher. What if I really felt like going through high crime areas is not what I want to prioritize? Is there a way that I can deprioritize those and choose areas where there's lower crime? And that's that crime score cost we built earlier, right? It really is nothing more than the weight for crime, right? High crime is 5, low crime is 1, times the distance. And even building a simple abstract weight like that, if I run it and then wait to see the same thing, what I'll eventually notice is that it's going to scooch itself a little to the right. And it's going to scooch itself a little to the right. Because even though it wants to minimize distance, it has a weight that we ascribe to it with crime. And because it's trying to avoid those, it's going to choose a different route, right? A different way that avoids crime as much as possible. Cost, time, distance, abstract. You can create whatever you want to mean cost. And then when you model things with routes, right, or the other skills we're about to learn, service area and closest facility, it will try to minimize that cost. And in this instance, it was trying to minimize proximity to crime.